So polar and nonpolar don't naturally mix, but we can persuade them. In the case of asphalt paving, it takes a tremendous amount of heat energy to persuade the asphalt, a nonpolar oil, to coat the rocks made up primarily of polar molecules like quartz. However, at Ingevity Pavement Technologies, we've discovered a way to replace much of that heat energy with chemical peacemakers. Molecules that can bring together substances that would otherwise be, well, polar opposites. They're called surface active agents, or surfactants, molecules derived from fats that have both polar and nonpolar qualities. The classic surfactant molecule. It has a polar head and a long carbon chain for a tail. For the sake of demonstration, we'll use a bit of shorthand and transform our surfactant molecule into what we call a lollipop. If we could see what was happening at a molecular level, magnifying the molecules over 1 trillion times, and we added our lollipops, our surfactant molecules, to a beaker full of H2O, the surfactant molecules immediately go to the interface, and the polar heads, doing what nature likes, are drawn to the polar water molecules. But when the surface is saturated, when no more surfactant molecules will fit, something really interesting happens. In a sort of dance, the excess molecules find each other. The nonpolar tails all want to be together, and the polar heads all want to be together. And they form spheres called micelles. Now, I'm sure you're thinking, that's all well and good, but how does it help me? For that explanation, we'll turn to the most well-known surfactant on the planet, soap. That's right, soap is a molecule derived from fats that has, ta-da, a polar head and a nonpolar tail. So, if instead of a beaker of water, we have a glass that contains not only water, but also remnants of cooking oil, and we add our soap, or surfactant molecules, they do the same thing that they did before. But this time, the nonpolar tails of our soap molecules and the nonpolar oil molecules are drawn together. The oil is captured within the micelles and can now be easily rinsed away. But where do these miracle molecules come from? And how do we use them to help make our planet and your lives better? Evotherm Chemistry 101, coming up next.